right, well, good afternoon. My name is Martin Flood. I'm VP Special Projects at GeoQ Group, and I'm going to talk to you a little bit about processing some power line data, looking for encroachments on the wires. So this is a fairly common application that a lot of our customers use LP360 for. They'll go out into the field, they'll collect LiDAR data with one of our drone sensors. This particular data set was collected with a TrueView 515, and then they'll process it through LP360, our desktop software, to identify the hits from the wires, vectorize those to create the catenary, and then identify objects that are encroaching on or danger objects that are getting close to those wires. So I'm going to start actually and show you the completed data set, and then I'll walk you through some of the process that we do in LP360 for that. So this is a data set. This was collected about a year ago, spring of 2022. It's actually from a section of transmission line in Brazil. As I mentioned, it's collected with a TrueView 515. This particular section is about 10 kilometers long. The entire project was about 220 kilometers of different circuits of different voltages. And what you're seeing here is the LiDAR data, the LiDAR point cloud. It's already been through all of the georeferencing, all of the initial processing in LP360. It's color-coded here by elevation, of course, that's the default. And there's a couple of additional feature layers in the map. So we have the center line, or the tower alignment. That's the purple vector that you can see running along the corridor here. And then we have the tower locations. Those are the blue dots you see. That's a feature layer showing the tower locations. That information was provided by the utility company. If you didn't have that information, there are tools in LP360 that would help you create that as well. Now, one of the nice things about having these as feature layers is it does let us work with the attributes that are on those features if you're going to work in a downstream in a geodatabase or some downstream workflow. Now, there's a process we go through, which I'm going to show you in a few minutes, to identify these encroachments. Again, that's basically objects that are getting too close to the wires. And I'll turn on that feature layer now. And so you can see the triangles. These are areas where LP360 has identified there's something getting too close to the wire. That too close really depends on the utility company. This particular customer, they wanted to find all objects that were within 5 meters of their wires. Now, because this is a feature layer in LP360, we can use some of the tools in LP360 like Feature Analyst. So I can select a layer in my map, just going to right-click here and bring up Feature Analyst. And essentially, I'm working in a GIS environment here where I can see the attribute table, I can see all the information, all the different data that's been collected about those features. In this particular case, you can see, we have obviously the locations. We have a comment section here. For this particular client, they were going to actually analyze the data themselves. So their staff, their technicians who have the domain expertise to identify the encroachments would be actually making the calls as to what the encroachment was. But as part of the QA/QC, we went through that as well and had our technicians update areas. So for instance, I can see here, here's one that's a crossing wire. If I select this, and I'm just going to drive to that location in the map. And it's a little bit awkward because I'm a little limited for screen real estate here. So let me kind of move this out of the way. And I'll just zoom in so we can see a little bit better. And I'm going to drop a profile or just a cross-section or cut here. Oh, come on. So that I can see these as a vertical slice through the data. And so you can see in this particular case, we've got a tree, and you can see, remember this is a cross section or a slice through the cables. So we can see our wires, our catenaries here. This is actually that tower alignment vector I mentioned earlier. And these are color-coded based on their distance from those wires. And so as I move through my feature table down here, I can update in the map hang on a sec, and move from encroachment to encroachment. That's a very effective way to review these for the technicians who want to make that judgment call or analysis on what the particular encroachment is. They don't have to go through the entire, in this case, 10 or 11 kilometers. They don't have to step through section by section. They can just drive directly to the areas where there's obstructions that they want to make some analysis on or make a judgment about. So that's where we end up. So how do we get to this point? So what I'm going to do is I'm going to bring up just a small section of this 10-kilometer stretch, just for purposes of working with a little bit smaller data for our demo here today. Now let's zoom into that layer. And the data here is all unclassified. If you've worked with LiDAR data, you understand about classes in the class table. If you're new to it, basically every LiDAR point can be assigned to a particular class depending on what it is. So it can be a ground point, it can be a hit on a wire, it can be a building, and so forth. So all of these points are all unclassified right now. Basically, we're starting where we're at. I'll turn off those previous encroachments. In addition to our profile in LP360, I can look at isometric views or rotatable 3D views as well in here. It might be a little bit easier to see as an elevation data set. So I can see the point line, the point cloud in here, and I can see the wires and so forth. I can see my tower locations. I mentioned that's a feature layer on my map. If I want to look at a span or the data from tower to tower, I can drop a profile across there. And again, I'm a little short on real estate because we've got a single screen here, but we'll work with that. And so we can see here, we've got good returns. You can see these wires in here. I'll zoom in a little bit closer so you can sort of see them. And actually, let me go in. I'm going to use our display control here. Just make things a little bit thicker. So these are the hits on the wires. These are what we want to extract and turn into catenaries, vectors. Catenaries, of course, that's the way the cable hangs between the two towers, and we can create a vector that represents that catenary. So we're going to use some point cloud tasks here. Let me just get that set up here. So on the left-hand side here, you'll see I have my point cloud task menu. So point cloud tasks in LP360 are essentially macros or scripts that you can run to do some sort of analysis on the data. This particular one, of course, is our power line extractor. It's going to run a search across my points. It's going to find points that it thinks are on the catenary, and then it's going to do some analysis to try to trace that catenary. And points which form a good catenary between the towers, it'll identify those as wires, it'll vectorize those, and then it will also classify them to the wire class, which if you're using the standard class table is class 14. So let me just put this profile away just for a matter of screen space. Now these point cloud tasks vary in complexity. This power line one is relatively complex in that it does have some user parameters that you need to set based on the data that you're searching. And of course, we cover all of that in our training. But I'm just going to go ahead and run the default here. And to do that, I'm just going to bring up my, my point cloud task toolbar. I'm working with my demo spans here, and I'm going to go ahead and run this on my demo spans. And this will take about 40 seconds or so to run on my machine. So what this algorithm is doing, as I mentioned, it's basically doing a 3D search. It's looking at all the points along within a certain distance of that tower alignment, and it's trying to determine points in that 3D. It's essentially a voxel search that fit along that catenary line. And the ones that meet that requirement, it identifies as potential wires. The ones that don't, it of course dismisses. It actually took a little bit quicker than I was thinking there. And now if I go back to my profile, So you can see I've extracted here. Those are actually vectors. I can select those. They're features now on that feature layer. Okay. So it's now an actual vector or feature in my map. The nice thing about that is similar to as I was showing you earlier with feature analysts. I can come in, I've got a new layer on my map. It's my wire vectors. I can go through, I can bring up feature analyst. And again, I'm in a GIS type environment now where I can see some of the parameters related to catenaries. You don't need to dive deep into the math of what a catenary curve is. We use these in some of our QA/QC to make sure that we have good catenaries. The algorithm, like any algorithm, can get some false positives where it thinks things are a wire, like a bunch of tree points and stuff, and draw a catenary that goes shooting off into nowhere. Usually quickly checking some of the parameters here, and again, we covered this in training, will let the technician quickly identify any bad catenaries and remove them. This is such a short span, and the data set's pretty amenable to the parameters I used, so everything looks pretty good looking at these numbers. So now that I have a set of vectors and a fan,
You have fans.
I have fans, yes. Power lines are very popular. But now that I have a set of vectors, what I want to do is I want to do that encroachment detection. I want to go find things that are too close to the wires. And again, if you look at this in cross section, cross section will come up here in a second. Here we go. So you can see the wires are up here. This is a fairly open area. I'm not really going to be too worried about this in here, but I don't want to have to visually go through and check these. So again, we're going to use a point cloud task. We're going to automate the encroachment checking. So I go back to my point cloud tasks. Again, if you're not familiar with LP360, these point cloud tasks, you can create a catalog of these tasks. So out of the box, it comes with a set of built-in filters and scripts and point cloud tasks to do various standard tools. But you can customize those and build up your own library. We have a point cloud task manager here. I have a very large collection of tasks that I've built up over the years. Most users would not do that. But you can take these point cloud tasks. You're not locked into our logic or our set of parameters for using them. You can basically create your own tasks. Okay, so now that we've got the wire hits identified and we've got the catenaries extracted, we can do that final step, which is to identify the encroachments or the danger points. Again, we're going to do this with a point cloud task. So I'm going to do my point cloud task here. And I'm going to select a classified by wire. This is going to give me my danger points. In this particular case, again, for this particular customer, they were interested in objects within 5 meters of their wires. That's entirely up to the user. That can be configured for whatever encroachment zones and any number of encroachment zones that a particular utility is interested in. This customer actually used 3 encroachment zones, of which 5 was the closest or the danger zone. So I'm going to go ahead and run this task. And again, similar to the, let me just make sure I got the right task here. Here we go. This one's a little bit simpler than the power line extractor. Basically, I just need to feed it in the lines that I want to check on, what my active labs layers I'm checking, and down here you can see this is where I set my distance for my encroachment. So this is set to 5 meters at this point. So I'll go ahead and run that. And in this particular case, because again, I've created those wires and other features in my map layer, so they're layers in my map, I can run against specific layers or even specific features on certain layers. In this case, I want to run against my wire vectors for my demo span, which is right here. And I will run against all of them because we're just using a small subsection here. So we'll go ahead and run that. And this will take a sec to run here. So This particular algorithm, this particular point cloud task, basically does a radial search around the wire vector that we just calculated. So it's doing a straight 3D distance from the vector to the point. It doesn't make any try to make any assessment of what the point is. It's simply identifying points that are within that zone. So I'm just letting this run here for a second. There is a third step that, just for time purposes, I won't show you today, but with many of the utility customers, obviously this classification is going to feed into some downstream workflow. They're going to have someone who's making some determination about some work instructions, or sending a field crew out to cut down the trees that are encroaching and so forth. Often those teams don't want to work in the point world. They don't want to work with LiDAR data. It's too heavy, it's too big. They just want to have simple locations where they can send a field crew and say, hey, there's some trees within 5 meters here. So there is a step, again, we don't have time today to run it, but there is a step where you can run which will take these encroachments that we find and basically cluster them. So basically take all of the points that are from basically the same tree or the same obstruction or the billboard that's in the way and reduce that to a single XYZ location, which you can then feed to your field crews, because a field crew simply just wants to go to a location and say, oh yeah, there's the tree, now I can go cut it. Okay. It does tell us, it found 9 obstructions or 9 encroachments within that 5 meter zone. Again, I can go back to Feature Analyst. I've used this several times. So we can now go in and look at our encroachments in our Feature Analyst. We saw this at the beginning. This is basically where the technician would end up with a list of all of their encroachments. Of course, with a fresh data set, they wouldn't have any comments or action items or anything in here. But it does give you a sense of how you can flow this into downstream workflows. If I want to look through some of these, I can see that some of them are more critical than others. Here's one, for example. Let me just click on my tracking. We've got one here that's a house within 1.6 meters. That sounds pretty dangerous. So we'll just go take a look at that one. And that's this encroachment right here. I'll just pop that up to end if we look at that in the isometric view. And again, I'll switch it to elevation display. It's a little bit easier. Oops. Standard elevation, not the psychedelic one. So here we've got, it's identified this tree, which is basically growing up right underneath and right around the tower and right over this house that's right there. It's obviously something that would be a fairly dangerous situation. Probably want to go have some remediation on that right away. So to wrap up, to summarize, so we have a set of tools in LP360 through our point cloud tasks that let you run algorithms to identify wire hits from your point cloud, typically LiDAR data, vectorize those so you have the catenary curve that represents the wire, and then run through and check for points which are within a certain distance of the wire or your danger encroachments. You can also run a clustering algorithm to reduce those to single XYZ locations you can send to your field crews. So thank you for that, and that's what I've got today.